Hi, welcome back. Today we will solve the last three digits of 19 raised to the power of 402 using binomial expansion. So let's proceed. 19 same as negative 1 plus 20. Now 19 to 402 is same as minus 1 plus 20 raised to the power of 402. If you remember your binomial expansion, let's say we have a plus b raised to the power of 402, the same as a to 402 plus, this one denotes the combination 402 taken 1 times a to 401 b to 1, and so on and so forth until b to 402. In the expansion form, the exponent of a and b is always 402. This one, 401 plus 1 is 402, 400 plus 2 is 402, and this a raised to the power of 402 have b raised to the power of 0, so it's still 402. For the combination part, 402 taken 1 and 402 taken 2, then the taken part, the 1 and 2 become bigger and bigger until you reach the 401 and 402. This one is 401. 402 taken 402 same as 1, and in the first term 402 taken 0 is equal to 1. Now we set a equals negative 1 and b equals 20. So we have negative 1 plus 20 raised to the power of 402. So equals 1 minus 20 times 402 taken 1 plus 400 402 taken 2 minus 8000 402 taken 3 plus so on and so forth until you reach the b raised to the power of 402. A being negative 1, when you raise to even exponent become 1, and when negative 1 raised to the power of odd power become negative 1. So a to 402 and even become 1, and a to 401 same as minus, then b to the 1 same as 20 raised to the power of 1, so we have 20, and still we copy the combination part 402 taken 1, and this term 400 is came from 20 raised to the power of 2, so 400, and a to 400 same as plus 1. So as you notice, we have alternating plus and minus sign. So for the last term, negative 8000 402 taken 3, so we just repeat the process until we reach 20 raised to the power of 402. You might notice why we only stop at 8000 combination of 402 taken 3, because we are only looking for the last 3 digits. The following terms have many zeros at the end, so adding them or subtracting is just another zeros at the end. 8000 is the result of the cube of the 20, and when you raise the power of 20 to a more bigger, so it gives more zeros to our terms. By now, you may already know the concept why we use the binomial expansion to find the last 3 digits of 19 raised to the power of 402. Simplifying further, we have 1 minus 20 times 402 plus 400 times 401 times 201 minus 8000 times 67 times 401 times 400, so on and so forth. So how do we get these values? By combination, n taken r equals n factorial over n minus r factorial times r factorial. So for 402 taken 1, we have 402 factorial over 1 factorial times 402 minus 1 factorial, which is 401 factorial, equals 402 factorial is same as 402 times 401 factorial over 1 factorial times 401 factorial. 401 factorial cancel out, so remaining we have 402. So second term, negative 20 times 402. For 402 taken 2, we have 402 over 2 factorial times 402 minus 2 factorial, 400 factorial. So 402 factorial same as 402 times 401 times 400 factorial over 2 factorial, 400 factorial. So the 400 cancel, remaining 402 times 401 over 2 factorial, same as 2. So we can cancel out 2, become 201 times 401. So the third term, we have 400 times 401 times 201. Okay, we already know the process. So 402 taken 3, same as 402 401 times 400 times 399 factorial over 3 factorial, 399 factorial. 399 factorial cancel out. 3 factorial same as 3 times 2 equals 6. So 402 is divisible by 6. When you divide 402 by 6 is 67. So the fourth term, we have 8,000 times 67 times 401 times 400. And the next terms after this one also have more than 3 zeros at the end. Again, because we only need the last 3 digits. So adding and subtracting zeros is just another zeros at the end. Okay, for now, we just need to add the first 3 terms. So 1 minus 8040 plus 32240 equals 322,32361. Let's take for now the last 3 digits of our sum of our first 3 terms. So 361. When we notice a number with the ending digits 361 subtracted by a number with ending digits of a lot of zeros will give ending digits of 639. And when the ending digits are 639 subtracted by a number with ending digits of a lot of zeros will give ending digits of 361. So after deducting 2 times, we'll return to our original ending digits, which is the 361. This is important because after minus 8,000 times 67 times 401 times 400, we have an alternating sign plus minus until we reach the 20 raised to the power of 402. So the last 3 digits of the first 3 terms are 361. When we subtract, become 639, and when we add, still the same, and we deduct, return to 361, then it goes on forever. We notice that every 4 terms we return out 361 ending digits. Now all we need to know is to find how many terms after the third term. In binomial expansion, we always plus 1 to the exponent to find the total terms. So 402 plus 1, we have 403 terms. After the third term, we have 400 remaining terms. So how does the 400 remaining terms will help us. Remember that every fourth term we return our original ending digits, which is the 361. Since 400 is divisible by 4, it is telling that we just return our ending digits 361 after adding and subtracting many times. So finally, the last 3 digits of 19 to 402 is 361. So here, by Wolfram Alpha, 19 to 402 equals to this number, and the ending digits is 361. That's all. Thanks for watching.